Welcome to Engineering Scale Models. I'm Jason, your host, and I do models. We're going to take a look at some more basic electronics with our Make Electronics 2nd edition by Charles Platt. So, I hope you guys liked the first two experiments I did. I believe I did experiment 3 and experiment 4. And today we're going to look at this experiment 6. Skipping 5. I'm not into making the battery with a lemon. That's just not... Yeah, I'm not getting that kind of mess out here. The only liquid on my bench is my iced tea. I keep that on the bench, but my coffee is off to the side, so... Here we go. So, it's very simple switching. We're going to need a screwdriver. I have that. Some wire cutters. Some alligator things. Some switches. Battery, 470 ohm resistor, that is yellow, purple, brown, and a generic LED, and it is red because they made me blow up one and it didn't really blow up. I gotta get some hookup wire out of here. So go back into my cool kit and let's see here. I want to do a yellow hookup wire. Let's do yellow. Let's see how yellow treats us. And then wire strippers, which I use these Kinplex. They work pretty good. So I guess I can turn this on now. Lighten everything up a little bit. Might be a little too much. Alright, so, well, that's bright. Okay, so let's take a look at what they want us to do. We don't need that. Let's make some room here. Got a little pile of gizmos. Still not using a breadboard, which is sad. So it wants us to hook up two wires on these things with no screws. So that's interesting. So let's get these switches out. So yeah, this is going to be interesting because there are no screw terminals on the switches that they... Well, not this guy included in the pack, but the people who made the pack didn't give me screws. Now these are single pole double throw switches, and let me explain to you what that is. This one is the central. You're not going to see that. Sorry, normally I do this, but the camera wasn't low enough for you to be able to see this. So you have this right here, and this is the central, and if the switch is in this position here, these two are a closed circuit. If it's in this position, these two are a closed circuit. Now let's just check that to be sure. Let us grab our little meter here. Should we use the cheapy meter? Let's use the cheapy meter. Not that cheapy meter. Let's use the cheapy meter. The cheapy meter doesn't have a conductivity check on it, so the cheapy meter's out. I have so many meters it's hard to keep track of which ones do what. Okay, so we're going to put this on to the little conductivity. Okay, it's the little speaker. I'm going to have to turn that off. Wow, you guys can't see that at all. Okay, 1 moment, please. That's going to be a little bit hard to read there, so let's just see what this looks like. There we go. That is going to be readable. Plug some leads into it. And around the camera. I know I could put it on the screen, but I'm going to be switching between stuff on a regular basis, so. Alright, so we're going to go to Conductivity right there. So if we touch these together, we get a beepy. So I'm going to come over here and I'm going to touch this to the middle one. And right now the switch is, it's in the closed position. It's open here and it's closed that way. Now if I switch to this one, now it's closed that way and open that way. So the middle one is central. That's the central one you want to see. So we have that figured out. So it wants us to connect an LED to the center of this switch. So let us do that. Could break out the soldering iron and just solder this stuff. Now it looks like we got to hook up the negative, which is this way. So that is going to go to the middle of this switch, and then this side is going to go to this side, and I'm not even quite sure what's going on here, but we're going to find out, because this is a lot of complexity for two switches. Okay, so we have the switches hooked up. We just need the power to the switch. In the middle there. None of those are touching? No, none of those are touching. And I looked at one of those loom cubes, and now I'm like blind. Wow, one of my eyes I can't see. It's crazy. So this is the positive. It's the positive. Okay, so here's our LEDs. This is why I like to use a breadboard, but I want to follow what they're doing in the book. So where's my resistor here? So I'll hook my resistor, and I am seriously out of jumpers. Well, we're going to do this. We're going to put an amp meter in line with the battery so we know how many amps we're drawing. So that'll be our jumper. So I will set my meter up for amps. I will put it on DC amps, and I will connect this one to this one, this one to this one. Okay, so we are connected through the negative, so we're going to go to the negative to the positive so we can keep this straight. We're going negative through the singlet meter set on amperage. That's going into the 470 ohm resistor that is yellow, purple, brown, through this white jumper into the into the negative lead of an LED, because I had that LED backwards. So negative lead of the LED going to the center of this switch here. Now the right side of this switch goes to the left side of this switch. The middle of this switch goes to the battery, the positive of the battery, and then the right and left side of this switch and the right side of this switch right here go to each other. They connect to each other. So let's see if we can't figure out. Okay, so in order to make this work, I need to just flip that. Yeah. So this is the light. The LED's lit, and we're drawing 4 milliamps, which is just this battery just puts out the weirdest. It's just. I mean, hold on a second. Let's just calculate what it's supposed to be. Okay. So Ohm's law says V equals IR. So let's turn on the calculator. Let's calculate, and then we have. So if I'll just work it out for you right here, because this has plagued us in a couple of videos about this battery, and we have it's V I R like this, and you put it in a circle like this, and then you got V equals IR. So resistance times current equals voltage, and if you need current, you do voltage to resistance divided by voltage. So we know we have a 470 ohm resistor, and then we have 9 volts. So 9 divided by 470. 470 divided by. So 9 divided by 470 equals 0.019. So 19 milliamps, 0.9 amps. So this is actually 19 milliamps is what this should be drawing. But let us get exact numbers and find out why. So let me disconnect my meter, and let's go into resistance reading, and we're going to get the exact resistance of this resistor here. We're not going to do 4-wire resistance because we don't need that. So that would explain it. Switch my leads. Yeah, when you switch at a current, it should beep to tell you to switch the leads. Okay, so we have R equals 459 ohms. So that's 459. Okay, now let's check the voltage on this battery. Check the voltage on this battery here. And it's 8.65. Well, let's just plug those two in and see if we get 8.65 divided by. That's 18 milliamps. So somewhere in. So let's just do. We were drawing 4.5 milliamps on the meter. So we can find the total resistance of the circuit. So voltage divided by current. So 8.65 divided by 4. Oh, yeah, I totally did that wrong. 4 milliamps is 0.004 divided by. Okay, so it should be about 2100 ohms is what the total resistance of that circuit is. The equivalent resistance of the circuit. So the equivalence resistance of the circuit, 2100 ohms, roughly. It was roughly 2100 ohms. So the resistance of the wires and all this wire resistance and whatnot is getting us about 2000 ohms when we're putting that resistor, this resistor in there. That is strange. What happens if we just get rid of... I'm going off topic on switches here. I'm going to get back to the switches in a second. Because you guys might run into this problem, wondering where all your amperage is, and, you know, think you did something wrong, and it's just weird. So I'm going to unhook this from the battery, and I'm going to come back in here, and I'm going to draw some current. And I am going to current. So I'm going to go directly from the battery to the positive leg of the LED, and then I'm going to clip these together with that, and I'm just going to touch these two together. And we're still getting 4 milliamps, so this battery is just garbage. This battery is it's like capped at 4 milliamps no matter what you do. What happens if I just put the LED across it? So if I just straight pull the LED across it, it's 7 milliamps. It's like a yeah, that's weird. You know what? We're gonna continue to never mind, I don't have that working. Yeah, we're gonna evaluate this in a separate video. I'm gonna break out the actually we're gonna just make this crazy video here. Sidetrack Central. I am gonna get my electronic load, and get my power plug here. I'm gonna get my book out of the way because this is gonna get hot. Put my bookmark in there. And we're going to do this as a test here. I believe this runs on 12 volts. We're going to find out. Uh. Oh. That would help. Plug it in the right spot. Okay, so this is a load. This is not the load I would prefer, but it's the load that I have. There's the screwdriver I want. I'm going to see what happens when I pull a load on this cheap battery here. This side is negative. Okay, I got 8.8 volts on there. So it's... Now let's see what happens when we put a little bit of a current load on it. Well, I put 10 millivolts on it and it dropped to 0.15 volts. $10 milliamps and it drops to 0.15 volts. I don't know if you guys can see that, but if I just come up here and I put 0.01, say 10 milliamps, and it drops the voltage to 15 volts or 0.15 volts. That is a super crappy battery. Okay, so now that we have that solved, let's turn that off. Let's unplug it. Let's get this battery out of here. Okay, that's how you test a battery, guys. That's just a DC electronic load. You don't need this specific load. It was the one sitting right in front of me, to be honest with you. I have a smaller one that runs off USB, but to be honest with you, I don't know how I would have powered it. This cable I have plugs in from my my power supply right there, so that is a handy thing. So basically that battery is shot. So we're going to throw that away or recycle that. I'm going to throw it away. I'm going to recycle it, and I'm going to grab another battery over here. So we have a battery here. Let's check the voltage of it. Make sure it's still good. Let's put that on there. DC voltage. .8 volts. Okay, so now in theory this should blow. I plug this on here. I separate these two, and I take one end of my meter from the negative side, and I'm going to plug me into current mode. and select current. And then we're going to go into the resistor, and then we're going to clip to the negative side of the LED. And then we're going to go from this side, the positive side of the LED, to the positive side of the battery, and that lights much better, and we are getting 16 milliamps, what I should be getting. So that was the battery. And you guys got to see how to check a battery to see if it was garbage or not. You put a load on it and you measure the voltage. Now, you don't have to have a load tester. You just need some resistors. Now, we could have checked that battery to see if it was still good with just some resistors. And I'm going to show you how to do that right now, because this is an interesting topic. Switches, you throw the switch stuff lights, okay? This middle one is the common, and then these two are according to which way the switch is thrown. You have multiple switches together to make some kind of code game where you gotta have the switches lined up. It's nothing to it. There's double pole, single pole switches, which would have the six on the bottom here instead of 3. Why is this so? Change that a little bit. Sorry, guys. You'd have 6 leads on here, and then you'd have 2 poles to connect to, and it would be the double throw. And you got single pole, single throw, like push button switches. Excuse me, I'm sorry. Single push button switches, things like that. But I am going to show you. Let's get that battery out of recycling, and we're going to disconnect this, disconnect this, disconnect this, put that over there. I do want this battery connector. Okay, I'm going to need a couple things for this. First, I'm going to need this meter back in voltage. Okay, and I am going to connect it across this battery, just like so. Now, I'm going to hook it up correctly. Now, let us do the formula here. So we have a 9-volt battery, so we know voltage. So we know voltage equals 9 volts DC. Okay. So we want an amperage. We want an A of 10 milliamps, 15 milliamps, and 20 milliamps. And you can go up in 100 milliamps, 1 milliamp, 2 milliamp. But this is what we're gonna do. And now we're gonna take this, and now this is 0.010, 0.015, 0.020 amps, and we're going to plug this in, and we're going to get some resistor values here. So we're going to plug this in here. We're going to get us some resistor values. So we're going to take 9 divided by 0.010. So we need, for this one, we need 900 ohms. And then we're going to go 9 divided by 0.015. And this one is 600 ohms. And then the next one is 9 divided by 0.02, 450. Okay, so I have the ohm ratings. So if I put one of these resistors across this battery right here, if I put this 450 across, I should get roughly 20 milliamps. Well, I so happen to have a 470 resistor right here. So we are going to continue to measure the voltage, but I am going to grab some leads here off of here, and I'm going to clip one end to there, and then I'm going to bring in my trusty amp meter, and I'm going to put it on, we're supposed to be getting 20 milliamps, so I'll put it on 200 milliamps. So, and this is going to go to the positive, no, from the positive. So I'm going to plug this in to the negative here. Just like that. And now I'm going to hook this up to the positive side. Now you look, I'm drawing, that meter, damn it. Ooh, sorry. I'm only drawing 6 milliamps. We know I should be drawing almost 20 milliamps. I'm drawing 6 milliamps, but look at the voltage on the battery. I'm reading the voltage across the battery. I'm only getting 2 volts. So you can see that this battery is shot just at 5 milliamps. It's dropping the battery voltage down to 2 volts. So that's how you can test your own battery without a load. Load makes it fun. And you know exactly when your battery's bad. That's the nice thing about a load. Not that load. That load only has 10 milliamp resolution. But if I can get the singlet load tester, I believe that has 0.1 milliamp resolution. So we covered a good chunk of stuff today. We did our make electronics. We did our switches here. We talked about our switches. Like I said, there's tons of different switches. If you got the book, well, I can tame that down now. You know, if you get the book, read the book. It's fantastic. I don't make any money if you get the book. I just think it's a fantastic book. You know, it goes into all kinds of symbols, and it's just a great reference book for different types of things. And then we start talking about LEDs and wire layouts, and you know, now it's talking about investigating a relay. So that'll be the next thing we're going to do here. We're going to do this experiment 7, investigating a relay. Looks like we're going to need 9-volt battery, the 2 relays, tactile switch, some test leads with alligator clips at each end, 5 of them, and a utility knife. I don't know what we're going to need a utility knife for. Hopefully we're not cutting one of these open. Yeah, we're going to be cutting one open. Alright. So that is where we will pick up in the next basic electronics. That is basically how a switch works. So that's about all I can say about that. I hope you enjoyed the little add-on test to see if your battery was garbage. So you can make your own electronic load. Now, guys, listen. I need to say this. Don't take your 1/4 watt resistors and put them across your car battery to test its load. Don't do that, please. Please do not do that. These have a quarter watt rating, which means they can take 250 milliwatts. Okay? That's it. They can't even take a watt. These are tiny resistors. And a lot of kits that you get come with 8th watt. So, please, please, please don't put these resistors across anything that is going to overrate the resistor and burn up. And I don't want to see anything bad happen. So please do not put these resistors across your car battery to see if your car battery is good. A, it won't tell you if your car battery is good, and B, you're probably gonna hurt your meter because it's gonna pull more than 10 amps. So please do not do that. Be safe, think smart, and have a fantastic day. Oh, and don't forget to check out the social media. You can also support me on Patreon. There's also a GoFundMe page in the link below to help me raise money for some equipment on the bench. I need that electronic load and a couple other things. Plus, I want to be able to pay for this stuff Singlet sent me to review for 2 months. So thank you guys so much.